Jeff with Lenco Diesel Performance and LDP Machine here for another Tech Tip Tuesday. What we're doing this week is something we want to do for a long time. It's going to answer one of the most commonly asked questions, not only to us, but that I see on Facebook groups and forums all the time, and that is, what bearings do I need for my engine build? I see people ask all the time, do I need H or HX bearings? We see that a lot, and we're going to show you how to properly answer that, because that question cannot be answered on a forum or Facebook or over the phone. It's answered right here by measuring. So we're going to show you how we measure and calculate bearing clearance and how to properly select bearings. So we have a 6.7 Cummins competition engine here going together. This customer brought us a lot of the components. He brought us bearings, HX mains, HX rod bearings. The HX, what that means, the H is hardened or high performance. That's your race bearing. And the X is 1 extra thousandths of bearing clearance. So 1,000th extra bearing clearance. So that's what the X stands for, is extra. So therefore the bearing, the ID is going to be larger. It's going to give you more clearance. So, this customer, just like many, was told to get X bearings, so that's what he supplied us. So that's how we originally first checked it. Now we have standard H bearings, the mains and the rods, and we'll go back and check them and show you how to calculate bearing clearance. So again, this is a question that can't be answered any way other than measuring. So we've got the crankshaft here. The crankshaft has been to our crank shop. It's been polished. First, they get checked for straightness, they get magnafluxed, and then they get polished. So we check them before they go to get polished, just a rough check. And then when they come back, we go through and measure every journal and document it. So this particular crank, I've measured the rod journals, the main journals, documented it. Now I've got my engine block here. I've got standard H series mains. I've got my girdle, I've got my studs, everything's torqued to spec. And I'm gonna go through with the dial bore gauge and I'm gonna measure the ID, and we're gonna calculate the OD of the journal, the ID of the bearing, and that's how we're gonna come up with our bearing clearance. So in order to do that, you need a micrometer to measure the journals. And then in order to measure the ID of your bearings, you need a bore gauge. So we have a standard bore gauge here, a dial bore gauge. This is a sun end, this is an extra long one. We have a standard length, and then we have several different sizes. But this is a very good high quality precision measuring instrument. And then we also have a digital one that I use for rods, use a lot of times for wrist pin bushings. This is a Fowler. This one's nice because it covers a huge range, but what's really cool, it's so fast. You don't have to worry about miscalculating when you're reading the gauge. So this is a digital one. But the downfall of this, you cannot get in there to get number 4 main accurately. So that's why we have the extra long one. So that's the tooling that you need. Micrometers, which you need a 2 to 3 for the rods, a 3 to 4 for the mains, and then dial bore gauge. So like I said, I've already used the mic. I have measured my journals on the crank. Then I set the dial bore gauge in our setting fixture, which I'll show you here in a minute. And now we're gonna go through, and the number that we get is gonna be the difference, or the bearing clearance. So I'll just check one of them here to show you. So we're coming in, and the important thing is, whether you're on a rod or main, you want to be perfectly straight up and down, because your bearing clearance is the tightest straight up and down. It's actually looser on the sides. That's kind of like a reservoir, and also lets the oil escape too. So you always want to make sure you're checking in line. And when we get to the rods, I'll show you the proper way to check them. So you've got your oil groove in the center here. So you want to check in front of the oil groove. Make sure you're not in it. Perfectly straight. So try to switch around here for the camera. So we rock this up and down. The smallest reading is going to be accurate, and it's 4.1 to 4.2. Now I'm going to jump to the other side of the oil groove, check it as well. So we're checking on both sides of the oil groove, and we're right at 4 thousandths. Come back here and check it again. Try to get centered between the oil groove and the outside of the bearing. Okay, yeah, come up around 4.2. So a couple tenths of a thousandths of taper, that's pretty normal. Your housing bore, meaning the block or the cap, could have a little bit of taper in it. The bearing sometimes made a little taper. A couple tenths of a thousandths is pretty normal, no big deal. So 4 thousandths clearance is what we have. And again, that's because we mic'd the journal of the crank, we used the dial bore gauge, and we measured the inside diameter of the bearing, come up with 4 thousandths. So if your journals are always going to vary by a couple tenths, sometimes maybe a half a thou or more. So it's important to go back and calculate based on the size of the journal and where the bore gauge is set. So this particular journal was actually a slight bit bigger than what I'd set my gauge to. So it's actually 3.8 thousandths is what it comes up with. So just under 4 thousandths. So 3.8 is what I come up with. That's right where we want to be. And again, that's with the standard bearing, not an HX. So if we would have just thrown the X series bearing, or yeah, the X series bearings in, we'd be up at 4.8 on that one. This one would be 5, so it would be 4.9, 4.8. On this particular application, that's not necessary. We would be 5.2 and 5.3 over here. So again, you have to measure. You can't just guess. You might get lucky, but your bearing clearance is very critical to an engine holding up, and it does need to be tailored to the application and what your intended usage. So sometimes we might want 4.5 to 5 thousandths if we're running straight 50 on a very high horse engine. And that also goes with rod selection too. So on the connecting rods, same principle. We measured our journal, we documented it, and we've got the digital bore gauge. So on an angle cap rod, you want to check in line with the caps, with the bearing. So I should say perpendicular to the caps. So you're not checking in line with the rod, you're checking, perpendicular with your caps. So we're gonna come in. Smallest reading. So we have 3.6.5. So 3.6 thousandths is our clearance. So that's right where we wanted to be. I believe it was number 5 on this engine. Yeah, the crank pin of the crank journal was the smallest. So with an H series bearing, we were at 3.9 thousandths. So again, if we would have just thrown the X series bearings in, be almost 5 thousandths oil clearance on the connecting rod. Totally unnecessary, too much clearance. This guy will probably run 1540, maybe 2050 in the heat of the summer at the drag strip, but a lot of times this engine will probably be living with 1540. Does not need 5 thousandths clearance. So after measuring and calculating, all the rods got standard H bearings, and there was one journal on the mains that we did run an X bearing. It was close. Either way, it really could have worked. But before we measure bearing clearance, we go in and again with the fasteners being used, girdle if it's got it, we measure the housing bore. So we measure the main tonal without the bearings in, and we document that. And I look that over before I select bearings, before I check it, and my number 2 main journal was at the extreme small end of the spec. So it's still within spec, but it was in the small end. So therefore I know it's gonna get more crush. It's probably gonna need an X bearing there. So I just automatically threw one in on number 2, and it worked out okay. So it's not uncommon for us to have, H bearings in half of the mains, X and others, because we go through and we check every single one. So it's not uncommon to mix them. That's actually really common on Duramax and Cummins builds that will mix them, H and X bearings. So we keep them both on the shelf. If we open a box and we mix them up, we label the box, mixture of them. Sometimes you get an X bearing right out of the box that will have less clearance than a standard because that bearing wasn't made right. Or maybe you had the upper and the lower were both on the extreme small end of the tolerance from Clevite. So that's not uncommon, that's why it needs to be checked. So that just happened, I think, about 2 or 3 weeks ago in a Cummins. We had an X bearing that was about 1.5, or I think it was 1.1 smaller than what it should have been. So very important it's checked, and there's nothing wrong with mixing them like that. So over here, we have 2 more 6.7 competition engines. These will be the next 2 getting assembled. These are getting Apex rods, billet rods. That engine over there was Wagner billet rods, so all good quality stuff. We'll go through and we'll check all these. I've already mic'd these cranks, and so these are both late model cranks. You can see that we still haven't, removed the pilot hub off the back. So these are both late model cranks. I know for a fact this one here only had a little over 100,000 miles, maybe 104, 110. Don't remember this one, but they're low mileage late model. But both of these had been, sent to the crank shop already and polished. And between these two on the mains, there's a half a thousandths difference from the smallest on this crank to the smallest on this crank. And that's not uncommon. The range on the tolerance is 1/1000th of an inch. So it's not uncommon to have a difference like that. So if from here to here is a half a thou or a thou difference, now you're talking a thousandths difference on the bearings. You could theoretically be 2/1000ths difference with the same bearing, same engine, just different crankshafts. So that's why it's important to check to check them properly, as opposed to just taking somebody's suggestion, throwing bearings in. And also, you catch a lot of imperfections in bearings. We have caught a lot of bad bearings, either taper, where you check it on one side of the bearing to another. I've seen 7 to 9/10ths, a thousandths difference, so almost a full thousandths difference from one side to the other, and then you'd use a ball mic and check it, and you find the bearing shell was bad. I've seen where the bearing shell, you can tell, wasn't put in the die right when they formed it at the factory. It was crooked. We've seen a lot of thrust issues caused by bad bearings. So measuring them not only is good for bearing clearance, but you'll catch some defects too. So very important. As always, if anybody has any questions, feel free to let us know. The average person isn't capable of doing this in their garage or even a small shop because you're not going to have the equipment. So that's when you rely on the machine shop that you're using. The engine machine shop that you're trusting with your machine work should be capable of doing this. They ought to have a dial bore gauge, micrometers, and be able to do this for you. So if you're not capable of doing it, pay them to do it. It's well worth it. And then I did want to touch just real quick on, I said about a setting fixture. So, we have, this high dollar tooling. We have sun-in dial bore gauges. And then this is the setting fixture. There's a couple different sizes for different ranges, but we come over here, we set it. Then I always check it in the micrometer to make sure that everything, the mic that I'm using to check the crank, I'm checking with our setting fixture, and then we go in and measure them. And usually after we check 2 or 3 mains, we'll stick it back in the setting fixture, make sure it didn't get knocked off a couple tenths, go back in and check them. So very precise, very important. So hopefully this helps. Like I said, anybody any questions, give us a call. Thanks.